Okay, so for this next unit in the class, we're going to look at how to create domains in a geodatabase and how to link tables in a geodatabase in what's called a relate. Remember, in the last unit we learned how to create a geodatabase, and I've got a simple one here over on the right in my ARC catalog. I've got a geodatabase called City Parks, and remember, in the last unit, inside of it we can think of a geodatabase as a sort of like a filing cabinet. The geodatabase is the filing cabinet. Last week we learned how to create featured data sets, which are like the drawers in a filing cabinet, and then we have feature classes, which is like a shapefile, and those are the actual files in the geodatabase. Now in this particular example, I do not have any featured data sets, and you don't have to have a featured data set in a geodatabase, and as you can see, I don't. I just have the geodatabase called City Parks, and then I have two feature classes inside. I've got a polygon feature class called Park Border and a playground equipment feature class, which is a point feature class. And so again, what we're going to learn how to do is how to create domains and then link tables and see how you can relate tables back and forth in a geodatabase. And hopefully as we go along here, you'll see what a domain is. And actually we're going to go ahead and talk about that first. So what I have here is again the feature class playground equipment and park border, and I'm just going to real quick show you this in Arcmap. The dots here are playground equipment in all of the city parks in Casper. In a past project in my advanced course, students went out for the city and GPS'd all of this data. And if we zoom in just to show you what the data looks like, for example, I'll zoom in on Washington Park here. We can see there, and if you've ever been to Washington Park, you kind of know what I'm talking about here, but each point represents a playground equipment, swing sets, slides, etc. So the point's the playground equipment, and then the red polygon is the border that goes around the playground equipment. And sometimes this border is made out of wood, sometimes it's made out of like plastic, composite material, and then inside that border they usually have pea gravel, crushed gravel, or wood chips where the playground equipment is. And so the scenario that we've got here, and this is what my students did for the city of Casper, they made a geodatabase for the city with the playground equipment and the park borders around the playground equipment, and they set up the geodatabase so that the city of Casper could use it to keep track of repairs that are done to the playground equipment. The city has to go out once or twice a year and inspect the playground equipment, make sure nothing's broke or there isn't anything that would hurt anyone that's playing on it. And the city wanted to see if they could use a GIS to keep track of inspections and repairs. And what I'm about to show you guys, the example I'm going to show you guys, is what my students set up for the city of Casper. And this was done back in fall of 2010, I believe, in my advanced class. So anyway, the whole goal of what we're going to learn how to do here is how to set up domains, and we're going to build a repair table that the city of Casper can input in who's inspected the playground equipment, who's repaired the playground equipment, and they can keep track of this all in the geodatabase. Okay. Most of this has to be done in Arc Catalog, so I am going to close Arcmap for now. And we are going to work strictly in Arc Catalog. Okay, and as you can see over here on the left, I've got it opened up to my geodatabase, and again we've got the park border feature class and the playground equipment. Okay, so first off, let's go ahead and just examine the playground equipment. So if I preview the playground equipment in catalog, we can see here's the dots. That really doesn't tell us a whole lot, but if we look at the table, we can see all the information that is in the playground equipment. So we've got, and who knew there was so much information about playground equipment, but we've got a column called bays, and what the bays mean is how many rows of swing sets there are. Equipment, there's some, and I can't remember what this code is, but this code stands for some sort of code that the city has. Now this is an important column. The name, this is the name that the name of the park that the playground equipment is in. Okay, for example, and these are abbreviated. So PVP is Paradise Valley Park. I'm trying to remember some others. WWP is Washington, or no, that's Westwood Park 1, I believe. I remember AP is Adams Park, so on and so forth. We've got the age group of the playground equipment. There's adult, child, 2 to 5, and 5 to 12, and then the manufacturer of the playground equipment. Okay. So just to show you what the data was all about. So the first thing we want to do in this example, again, remember the whole goal of what we're going to go over here is how to set up a repair table that the city of Casper can use to keep track of who has inspected and repaired the playground equipment. Okay. So the first thing we'll do is let's go ahead and create the repair table. Now this is just going to be a standalone table. This table isn't associated with any points, lines, or polygons. This is just basically an Excel table that exists in the Geodatabase. It's going to allow the city to keep track of repairs and inspections. All right. So to create a standalone table, I'm going to right click on my Geodatabase and I'm going to go to New, and I'm going to click on Table. And I'm going to name the table. So I'm going to go ahead and call this table, I'll call it Playground Repair. Click Next. Now this is where I need to think about, okay, what columns or what kind of information would the city want to know in an inspection and a repair table. Okay. First thing and there's a lot of different ways you could go about this, but this is what I would think the city would want to know. They'd want to know who is doing the inspection, right? And then probably the same people for the city inspect the playground equipment and repair the playground equipment. And so we could just call this column Employee. Okay, and that's going to be a text column. How about date of inspection? They'd want to know when someone went out and inspected the playground equipment. We're going to make that a date column. What else here? How about date of repair? So they'd want to know when they went out and repaired it. It's also going to be the type of column that will be date. They're going to want to know what was wrong. If someone went out and inspected the playground equipment and they found out something was wrong, they're going to want to be able to type that into the table, right? So let's just call this comment. That'll be text. See, what else would they want to know? Maybe how much the repair cost. So cost of repair, and we'll make that a number column. And we'll make it a double column so that we can put decimals in there. And then finally, and this is probably the most important column, they're going to want to know what park this playground equipment exists in. And this will become apparent why this is so important here in a minute. But we'll go ahead and we'll call that park name, and that's obviously text. Okay. Okay. There's probably other things we could have in here, but this is just an example to show you all how this works. So we'll go with that with our repair table, and we'll click Finish. And so you can see in my Geodatabase now, in my City Parks Geodatabase, I've got the Park Border feature class, the Playground Equipment feature class, and the Playground Repair table. Okay. So we've created our repair table. The next thing is, let's go ahead and learn about domains. So if we click the Playground Repair table and go to Preview, we can see that these are the columns that we just got done creating. And what a domain does, and what the domain did for the city of Casper, is it made it easier for them to input data into the table. So let's say if someone went out and inspected a park, they would come into the table and they would type in their name. Okay, if they went out and inspected, since they were an employee, they would type in the date of the inspection, they would type in the comment and the cost of the repair and the park name. Okay, what a domain can do is it can save time for people using the GIS by not having to type in all of these things. So a domain is like a drop-down list that you can select from a set of variables, and you won't have to type the information in. Okay. Now, if that doesn't entirely make sense, I think it will once I get in and create the domain. So the thing about a domain is if you want to do domains for a column in a table, you have to think about, okay, which of these columns could be domain driven? In other words, which of these columns has a finite number set of variables that we could put in the domain that someone could just click on and have it populate that row of data in the table and not have to type it in. Okay, so for example, employee. There's just a set number of employees that work for the city, like 5, 6, 10 employees. So if we could create a domain of all the employees' names, then whoever is inputting data into this table could just click on the name instead of having to type it in. Okay. Now, date of inspection and date of repair. Now, there's an infinite number of dates on the calendar, right? So that would be really hard to create a domain for date. Now, if we were, if I was a little more knowledgeable, if you were more knowledgeable on maybe how to program, maybe you could program a calendar into the table, kind of like the calendar that you can click on your desktop of your computer. Now, if we could do that, then that would be good. I don't know how to do that. So date of inspection and date of repair, they are not going to be domain driven. Okay. Comment. It depends on how you do it. Comment could be domain driven, but the employee needs to be able to freely type in whatever is wrong with the equipment. There would be no way we could come up with a set of domains that could fit every little thing that would be wrong with the playground equipment. So comment is not going to be domain driven. Cost of repair, it depends on how you do it. The way, for this example, what I'll do it is we'll just have a set of variables for cost that could be between, let's say, $0 and $10. Maybe $10 and $50, and then $50 to $100. Okay, we could do it that way, or we could just, and that would have to be a text column if I did it that way. Now remember, for cost of repair, I made it decimal or double, And so that means we just want to be able to freely type in whatever the cost of the repair is. But you could do it the first way I explained as well. Now park name. Now there's 35 parks in the city of Casper. That could be domain driven, right? So we could type in a set of 35 variables, and then just the employee would just then be able to click on that variable, and it would pop that name in, of the park name in there, and they won't have to type it in. So in this particular example, we have park name can be domain driven, and employee can be domain driven. Okay. So the first thing, let's go in and create those domains. All right. So to create a domain in a geodatabase, you right click on the city parks geodatabase, and you go to properties. And there's a general tab, and there's a domains tab. Okay. So domain name, we'll just call this employee. Now the domain name does not have to match the column in the repair table. In this case it does, but it doesn't have to. So domain name, in fact, we can just go ahead and call it city underscore employee. And you can give that domain a description. So all the city of Casper park inspectors. Okay. Now this is important. If you're going to associate this domain with a column in a table, the type of the domain and the type of the column in the table has to match. Now remember, employee was a text column in our repair table, so we have to make this domain text as well. If you don't do that, the domain will not work with the column that you want to associate it with. All right, so that's important. Now what I like to do is highlight the domain up here, and then what you have to do is type in now what you would do is here's where you create the domain. So in this case you're going to type in all of the employees that do the inspections for the parks for the city of Casper. And so you can give each employee a code, like you can give, here's employee number 1, and I'm just going to make some names up here. So John Doe, okay. Employee number 2, again, I'm just making these names up. I'll put my name in there, Jeff Sun. Employee number 3, running out of names to make up here, Mike Smith. 4, again, just making names up here, Joe Johnson. All right. Now, if you want to add more employees in, if there's more, that's fine. If an employee were to quit, you could delete this employee. If you were to hire an employee, you could come back in here and add a name. Okay. So pretty simple. Once you have all the domains created, click apply, and that domain is created. Now remember, the other domain we were going to have is the park name that the equipment is in. Okay, so we'll call this domain name park name. You can give it a description, name of the city of Casper park. Remember, park name is also text. Okay, so we need to make it a text domain. And then what we would do is, since there's 35 parks in Casper, we would need to go in and type in those codes for all 35 parks and then type out the name of the park. Now there's 35 of them, and this is just an example, so I'm not going to go ahead and do all that. I'm just going to go ahead and pick a couple parks, again, since this is an example. But if we were doing this for real, and my students did do this for the city of Casper back in 2010, they went through and typed in the code for each park and the name of each park for all 35 of them. Okay, but again, this is an example. We're just going to do a couple. So I remember PVP was, Paradise Valley Park. AP, if I remember correctly, was Adams Park. I think MSP was, excuse me, yep, was Mike Cedar Park. Now, was Cedar with an S or a C? I cannot remember. I think it's an S. Could be wrong on that. But anyway, there's our 3 examples. Again, remember, when my students did this, they did this for all 35 parks, okay? So I'm going to click Apply and click OK. And now our domains are created. Again, if we right-click on the Geodatabase and go to Properties, there's our domains. They're still there. And you can go back in and add and create domains as needed throughout the life of the Geodatabase, okay? Next thing we're going to do is these domains are hanging out in our Geodatabase, which is great, but the GIS doesn't know which domains to use with which columns. Okay? So the next step is we're going to go ahead and associate the domains with the appropriate columns in our repair table. Okay, so to associate the domain with the column in our repair table, it's pretty simple. We just right-click on the repair table. We go to Properties. We're going to go to Fields. So here's all the columns in our repair table. Now remember, employee was domain driven. So we're going to highlight employee where it says domain down here. Again, here's our domains that we created, and I misspelled city employee here. So we could go back and fix that if we wanted to. I'm not going to worry about it right now. But the employee column in our repair table goes with city employee domain that we created in our Geodatabase. Okay, so we select that, click Apply. Date of inspection, date of repair, comment, all of those were not domain driven. Cost of repair in our example was not domain driven, but park name certainly is, right? We want to be able to select the name of the park from a list. So we're going to highlight park name. We're going to go down here to domain, and we're going to choose park name. Click Apply and click OK. Now, it doesn't look like we've done too much here, but when we get through with this example and I show you how this will work, you'll see what we just did here. Okay. So just to recap. We've created a repair table. We've created some domains that we think will be useful for the city, and we've associated those domains with the appropriate columns in the appropriate table. All right. Again, remember the whole example we're going through here is we want to build a geodatabase that the city of Casper can use to keep track of inspections and repairs for all of the playground equipment in Casper. Okay. All right, next thing we want to do is this table is just sort of hanging out there by itself, right? So it would be good if we could relate this table to the appropriate feature class, okay? And if we relate it, what can happen is if we highlight a repair inspection on our table, it'll highlight that point on the map. And vice versa, if we click on a point which represents a piece of playground equipment, it'll highlight all of the repairs that have been done to it throughout time. Okay. Again, that's kind of a little hard to explain, but you'll see what I'm talking about here in a minute. So let me show you how to relate a table to a feature class. Okay. So to create a relate, we're going to right click on our Geodatabase and we're going to go to New, and we're going to click on Relationship Class. And this particular relate is going to be for the playground equipment, so I'm going to call it Playground Equipment. I'll just abbreviate equipment and I'll call it relate. Okay. Now the origin, and what you're going to do here is you're going to work through this relationship wizard that helps you build a relationship in a geodatabase, okay? So the origin table is always the information on your map or the information in your geodatabase that is associated with a point line or polygon, okay? Now in this example, the playground repair table is just a table. It's not associated with any sort of geographical data on a map. But the playground equipment is. It's a feature class. It's a point feature class that represents where the playground equipment is in Casper. So that's going to be our origin table, okay? So we click playground equipment. And then our destination table is always the table that is not associated with information on your map. It's just a standalone table. In this case, it is our playground repair table, okay? Click next. Now there's two kinds of relationships that you can build in a geodatabase. Simple is when the two tables that you're relating together are independent of each other, okay? So what that means is, so in this example, if the city were to get rid of a park, let's say they sold the land and whoever bought the land tore down the park to put up an office building, okay? So if the part got deleted out of the geodatabase, if it's a simple relationship, the repair information from that park would still be there, okay? Composite relationship means that if the park gets deleted, whatever is related to that park also gets deleted, okay? So in this case, we need to ask ourselves, or the city of Casper needs to ask itself, what kind of relationship do we want? If we were to somehow get rid of a park, do we want to keep a record of all the repairs? If we do, then it needs to be a simple relationship. If they don't want to keep a record of all the inspections and repairs, then it would need to be a composite, okay? It doesn't really matter in this case which one we choose. This is just an example. But let's just say the city of Casper decided, well, if they get rid of a park, there's no reason to keep a record of the repairs and inspections, so we'll do a composite relationship. So if a park gets deleted, everything associated with that park also gets deleted, okay? Click next. This is what the relate is going to look like when we switch back and forth between the points on the map and the repair table. So these names are okay. Here's where you can choose which direction you want to go in the relate. Forward, backward, both, or none. Okay, so what this means is if you want to be able to click on a park on the map and bring up all of the inspections and repairs that have been done to it, then that would be forward, origin to destination. If you want to be able to click on a repair or an inspection in the repair table and see where that park is on the map, that would be going backward. Or maybe you want to do both. In this case, let's say we want to be able to do both. So we're going to click on both. Here's where you need to pay attention to what is called cardinality. They call it cardinality in GIS. In other words, what type of relationship is this? Is it a one-to-one? In which case, in this example, what a one-to-one relationship would be is there's one part can only be associated with one repair or inspection. One-to-many would be one part can be associated with many relates or inspections. And then the other one that could occur, although that's not an option here, is many-to-many. Okay? In this case, I think we could all agree that throughout the life of a park, there could be many inspections and many repairs. So in this case, it's going to be a one-to-many relationship. Okay? No, we're not going to associate attributes with the relationship class. You don't need to worry about this. Just leave this at no. Click next. And this is probably the most important part of setting up a relationship, is there has to be between, in this case, the playground equipment and the playground repair table, there has to be a column in each table that is the same so that the GIS knows, okay, well, which repair goes with which park. Okay, there has to be some kind of common data or attribute that the GIS will know how to link the two tables together. Okay, so if you think about it, what's the one piece of information we have in both tables that's the same in between both of them, and that would be park name. Okay, so, and that's called, in the origin table, that is called the primary key. So the primary key is name, that contains the park name. And then in our repair table, this is called the foreign key in the destination table. In this case, the foreign key is park name. Okay. Again, there has to be an attribute between both tables that are the same so the GIS knows how to link them. In this case, it's the name of the park, which the primary key is name, the foreign key is park name. Okay? Click Next. This is the final screen here. It just gives you a summary of what we just did, and go ahead and click Finish. And now you can see here is our relationship. We've got a relationship that popped up. This is what is called a relationship class inside a Geodatabase. And this relationship class is linking the playground equipment to the playground repair table. All right. Okay, we're basically done now, although what we want to do now is let's add this data into Arcmap and let's test it out and make sure it works. Okay, so I'm going to close Catalog. I'm going to open up Arcmap. And I'm going to load in a project that has the world imagery. I'm going to hit my Add Data button. I'm going to go to my City Parks Geodatabase, and I am going to load in the playground equipment and the playground repair table. And I'm going to zoom in on the playground equipment. Okay, so here's our dots that represent the playground equipment in Casper, and here's our repair table. Okay, if we open up this repair table, we can see it's blank. There's nothing in here yet. Okay, but let's just pretend for a second. Let's say we are a City of Casper employee, and the city just sent us out to inspect a park, and let's say he sent us out to inspect Adams Park. Okay, so we went out and we inspected Adams Park, and let's say we found something wrong with a slide there maybe. Okay, so I'm going to find Adams Park first. So I'm going to open up the playground equipment table and I'm going to sort by name, and here's Adams Park. So I highlighted that row in my attribute table. You can see Adams Park gets highlighted here on the map. So let me zoom in on that. Yep, there's Adams Park. Actually, let me zoom back out here. Let me color code this a different color just so we can see it. Okay, yep, there's Adams Park. Now let's say we're back in the office. We were at Adams Park. We found something wrong with the playground equipment, and we want to log that inspection into the repair table, right? So we got back into the office. We open up the GIS. We open up the playground repair table, and we need our editor toolbar. Now, if your toolbar isn't up in ArcGIS, you need to go to Customize Toolbars. Make sure Editor is checked on, and we want to start editing. Okay. Now let's see, the first thing we're going to see here is let's see if our domains worked. So if we click here, double click, yep, here's our first domain. Remember, this is a domain we built for employee. And these are all of the employees that the city of Casper has that does the inspections, all right? So my name is Jeff Sun. The date of inspection, I'll just put today's date in. So 10/15/2016. This is an inspection. It's not a repair, so I'm not going to do the repair. Let's say the comment was, let's say, broken slide, okay? I'm going to estimate the cost of the repair is going to be $100. And remember, park name, now this was domain driven. So let's see if our domain works. Yep, it sure does. We were at Adams Park, so I'm going to click on Adams Park. So that's good. Our domains are working, okay? So there's my inspection, okay? Now let's say a few weeks later, another employee went out and they fixed that repair. They fixed the broken slide at Adams Park, okay? So we'll just double click. Let's say Joe Johnson went out and this wasn't an inspection, it was a repair. And let's say on 10, I'm just making a date up here, 10/20/2016, we'll just put in fixed, broken slide. The cost of the repair was estimated at 100. Let's say it came to 150.30 cents. And again, this was at Adams Park. Okay. Let's say, and just to do one more here, let's say Mike Smith went out and did an inspection on 10, just making another date up here, 25/2016, and he noted there was a broken swing set. Estimated cost of repair, we'll just say $50, and this was at Adams Park. Let's say I went out there a couple days later, 10/27/2016, fixed, broken swing set. The cost of the repair came to $60.50, let's say. And let's change this to Paradise Valley. Let's say that was at Paradise Valley Park, okay? So this is just some examples. Stop editing. We want to save our edits. So there's some edits that have been, or some repairs and inspections that have been added to the repair table. Now let's see how the relationship works, okay? Let's say you're in the office. The city manager comes in and says let's say they had a meeting over the parks, and they're looking at, they've been noticing a lot of maybe vandalism to the parks. I'm just kind of making some things up here, but they want to see, hey, how much money have they spent on Adams Park, okay? So, and your city manager is looking over your shoulder, and you want to be able to pull up how much money has been spent and all the repairs and inspections that have been done to Adams Park. So what you would do is open the attribute table, find Adams Park in the list here, highlight it. So we highlighted Adams Park. Again, you can show your city manager, here's Adams Park right here, if for some reason he didn't know where it was. I closed the attribute table accidentally. I'm going to leave it open. Okay, so I have Adams Park selected here. I'm going to go to my table options button. I'm going to go to related tables. Here's the relate that we just built to the playground repair table. So I'm going to click on that, and look what popped up. Everything that has to do with Adams Park is highlighted. Okay. Notice if I click on show all records, everything that's associated with Adams Park is highlighted. The other two things that are actually Paradise Valley Park are not highlighted. Okay. And the reason that's highlighted is because of the relate. This table is related to the dot on the map through a primary and foreign key, which in this case is park name. Okay. So then you can tell your city manager, well, so far we've spent $250.30. Well, that was just an inspection, I guess. So far we've spent $150.30 on Adams Park. Okay. Now remember, in the relate, we said we want to be able to go forwards and backwards. Let's say someone doesn't know where Paradise Valley Park is. You can click on a repair or inspections that have been done to Paradise Valley Park. You can go to table options, related tables, click on the relate for playground equipment, and then it highlights everything that has been done in Paradise Valley Park. So we can go forwards and backwards. Okay. This is about a 40-minute long video. It's kind of the longer ones we've had here in the class, but again, what we learned how to do here was set up a table inside a Geodatabase, create domains for that table, associate the domains with the appropriate columns in whatever table we want to associate it with, and then we learned how to relate the table back to a point line or polygon on the map, which in this case was a point, which represents the playground equipment. Okay. So what I want you to think about here is, I know we went through a lot here, but how did we save the city of Casper time? We saved them time. How does creating domains save time? And how does it make our data more accurate? Okay. So I want you to think about those, because there's going to be a discussion on that here in the next unit. Okay. So this is the end of the video. Again, we learned how to create domains and relationships in a geodatabase. I hope this was helpful. Obviously, as always, get a hold of me, text me, call me, email me, come in and see me if you have any questions over any of this. Okay? All right. That's it for the video.